The battle that saved the world. How makeshift carriers and rogue mechanics destroyed Hitler's ultimate weapon. Picture this. It's March 1943, and somewhere in the freezing waters of the North Atlantic, a merchant sailor clings to a piece of wreckage. He's been in the water for 11 minutes. In another 4, hypothermia will kill him. Around him, the ocean burns with oil from his ship's ruptured tanks. He watches a German U-boat surface 200 yards away, not to rescue survivors, but to count the kills before diving to hunt the next victim. This scene repeated itself every 4 hours, 24 hours a day, for months. And Britain was running out of time. The mathematics were simple and terrifying. German submarines were erasing ships from existence faster than American and British shipyard could build replacements. Every morning, Allied naval headquarters updated their projections, and every morning, those projections showed the same thing. By autumn 1943, there would be no merchant fleet left to protect. Without merchant ships, Britain would starve. Without Britain, there would be no staging ground for liberating Europe. Without liberating Europe, Hitler would consolidate his grip on the continent while developing weapons that would make invasion impossible. But here is what makes this story remarkable. The weapon that ultimately saved civilization wasn't a technological marvel dreamed up in some Pentagon laboratory. It wasn't a secret project involving the brightest minds of the age. It was a merchant ship with a flight deck welded on top, crewed by mechanics who ignored orders and pilots who violated every regulation in the book. And in 11 days during May 1943, these improvised warships and their rogue crews accomplished what seemed impossible. They broke the back of Nazi Germany as submarine force and changed the course of human history. This is the story of how America won World War II, not through superior engineering, but through something the Germans never anticipated: organized chaos, the graveyard shift. Admiral Karl Dunitz stood in his operations room in Paris, moving U-boat markers across a map of the Atlantic like a grandmother positioning chess pieces. Each marker represented millions of Reichsmarks, 50 highly trained crew members, and 6 months of precision manufacturing. He had 237 submarines operational in March 1943, and his tactical system was devastatingly elegant. The Wolfpack doctrine worked like this: position 20 to 30 U-boats in a patrol line stretching 500 miles across known convoy routes. When one submarine spotted merchant ships, it wouldn't attack immediately. Instead, it would shadow the convoy at periscope depth, broadcasting encrypted position reports every hour. Other U-boats would converge from all directions, forming a noose around the target. Then, as darkness fell, they would strike simultaneously from multiple bearings. Convoy escorts faced an impossible dilemma. If they chased one submarine contact, 3 others would attack from different directions. If they stayed with the convoy, U-boats could pick off stragglers with impunity. Either way, ships died. In the first 3 weeks of March alone, German torpedoes sent 83 Allied vessels to the bottom, representing over 590,000 tons of desperately needed cargo. But the raw numbers only told part of the story. Each sinking created cascading consequences that multiplied the damage far beyond simple tonnage calculations. When the freighter SS Bonneville went down on March 7th with 5,000 tons of wheat aboard, the grain wasn't just lost, it represented the cancelled bread rations for 200,000 British civilians for an entire month. When the tanker SS Vistula burned for 6 hours before exploding, the 12,000 tons of aviation fuel she carried would have kept 60 Lancaster bombers flying combat missions for 3 months. When convoy HX-229 lost 13 ships in 72 hours, the steel in those hulls would have built 40 Sherman tanks. The British Ministry of Food reduced rations again on March 15th. Meat dropped to 1 shilling worth per person per week, roughly enough for a single pork chop. Cheese rations fell to 1 ounce weekly. Eggs, when available at all, were limited to 1 per person per fortnight. Restaurant meals were restricted to 3 courses maximum, with 1 course consisting of actual protein. The ministry distributed pamphlets with cheerful titles like Make Do and Mend and The Kitchen Front, which offered helpful recipes for dishes like Woolton pie, a mixture of root vegetables held together by oatmeal and hope. But the pamphlets didn't mention the calculations happening behind closed doors. British agricultural production, even with every available acre under cultivation, could feed only 70% of the population. The other 30% depended entirely on food shipped across the Atlantic. If sinking rates continued through summer, rationing wouldn't be an austerity measure, it would be triage, deciding which segments of the population receive enough calories to survive. Convoy duty had become something worse than dangerous. It had become a statistics game where everyone understood the odds. Merchant sailors developed a grim form of situational awareness. When assembling for convoy departure, they would count the ships, multiply by the average loss rate, and know with reasonable certainty that 6 or 7 of the vessels around them wouldn't reach port. They just didn't know which 6 or 7. The escort destroyers assigned to protect these convoys faced equally hopeless mathematics. A typical convoy might contain 40 merchant ships spread across 50 square miles of ocean. The escort group would have perhaps 6 destroyers to guard them. A U-boat traveling submerged could cover for miles per hour. A destroyer racing to investigate a torpedo explosion could make 25 knots, but its sonar was effectively blind while moving at high speed. This meant that when a U-boat struck from the convoy's rear quarter, the nearest escort destroyer was at least 15 minutes away even if it abandoned station immediately, leaving other parts of the convoy undefended. 15 minutes was enough time for a submarine to fire all 4 boat torpedo tubes, reload, and fire for more. The typical result was 8 ships hit before the escort arrived to find nothing but debris, survivors, and the spreading oil slick that marked another successful German attack. Captain Donald McIntyre, commanding the destroyer HMS Hesperus, described the psychological reality of convoy escort in his after-action report from March 18th, heard torpedo explosions bearing 045 relative. Proceeded at full speed to position, found two merchantmen sinking, one already gone. Obtained fleeting sonar contact bearing 120 degrees. Contact faded before attack could be developed. While pursuing contact, heard 3 more explosions from convoy's main body, bearing 250 relative. Returned to station, found 3 additional vessels torpedoed, 1 burning. No further sonar contacts, submarine escaped. The report's clinical language concealed the screaming frustration of commanders who understood they were failing through no fault of their own. McIntyre had made every correct decision and still watched 5 ships die in 40 minutes. This wasn't a failure of tactics or courage. This was a failure of geometry. Too few escorts covering too much ocean against enemies who struck from underwater where detection was nearly impossible. American naval analysts had calculated the exact dimensions of failure. At current sinking rates, accounting for new construction, the Allied merchant fleet would cease to exist by October 1943, not diminished. Not reduced, completely gone. Every ship capable of crossing the Atlantic would be rusting on the ocean floor, and the ability to replace them would have been exhausted. General George Marshall received these projections in a classified briefing on March 22nd. His response, recorded in the meeting minutes, cut through the statistical abstractions. Gentlemen, without merchant ships, we have no way to move American forces to Europe. Without forces in Europe, we cannot liberate France. Without liberating France, we cannot defeat Germany. The war in the Atlantic isn't one campaign among many. It's the only campaign that matters because if we lose it, we lose everything else by default. Admiral Ernest King, Chief of Naval Operations, had already reached the same conclusion. He'd been advocating for escort carriers since 1942, but fleet admirals kept blocking the proposals. They wanted fleet carriers 30,000-ton warships with armored flight decks, 30-knot speeds, and 90 aircraft capacity. Escort carriers seemed like compromises, adequate for training purposes but useless for real combat. King stopped arguing and simply redirected funding. If the Bureau of Ships wouldn't approve escort carrier construction through normal channels, He decommissioned them as merchant vessel conversions and let bureaucrats discover what he'd done after the keels were already laid. This sort of administrative insubordination would typically result in forced retirement, but King understood something his critics didn't. By the time anyone court-martialed him, the war would already be lost or won, making the court-martial irrelevant either way. The first contracts went to industrialist Henry Kaiser, whose Vancouver shipyard had pioneered the Liberty Ship program. Kaiser's reputation was built on speed rather than elegance. When asked to build aircraft carriers, Kaiser applied the same philosophy that had revolutionized merchant ship production: identify the absolute minimum requirements for mission success, eliminate everything else, then manufacture that minimum requirement as quickly as possible using the simplest methods available. The result was the Casablanca-class escort carrier, and it horrified everyone who saw the specifications. The floating compromised the USS Casablanca looked like what she was: a merchant ship that had suffered an identity crisis halfway through construction. Her hull came straight from a Maritime Commission C-3 cargo vessel design. Her propulsion system used diesel engines intended for commercial freighters. Her flight deck was essentially a massive steel rectangle welded across the top of the hull, supported by framework that structural engineers examined with visible concern. Fleet carrier advocates compiled lists of deficiencies that read like indictments. The hangar deck could accommodate exactly 27 aircraft, crammed so tightly that mechanics had to coordinate their movements like choreographers to avoid collisions. The island's superstructure was so small that the bridge, flight control, and radar stations were stacked vertically in a tower that swayed visibly during turns. The catapult system was underpowered, requiring pilots to launch with reduced fuel and ammunition loads. The arresting gear frequently broke, requiring constant maintenance between flight operations. Admiral John Towers, chief of the Bureau of Aeronautics, summarized the fleet carrier community's position in a memo that dripped with condescension. These vessels represent everything naval aviation has fought against for 20 years. They are too slow for fleet operations, too weakly built for combat, and too poorly equipped to project meaningful power. Assigning them to convoy escort is the most charitable use I can imagine, though even there I suspect they will prove more liability than asset. The memo reached Admiral King's desk on April 2, 1943. King read it, initialed it without comment, and filed it in his opinions "I don't care about" folder. He'd already commissioned 30 escort carriers, with another 20 under construction. Whether Towers approved was irrelevant. The only question that mattered was whether these improvised platforms could put aircraft over submarines in the mid-Atlantic gap where land-based planes couldn't reach. The financial arithmetic was undeniable. Each Casablanca-class escort carrier cost approximately $6.9 million to construct. A proper Essex-class fleet carrier cost $104 million. For the price of one fleet carrier, Kaiser could deliver 15 escort carriers carrying over 400 aircraft combined. Even if escort carriers proved only marginally effective, the sheer multiplication of available platforms would still change the strategic equation. But effectiveness wasn't marginal, it was transformative, though nobody realized it until USS Bogue launched her first combat patrol on May 1, 1943. Commander Giles Short stood on Bogue's bridge that morning and felt the peculiar mix of confidence and terror that characterized carrier command. His pilots were trained and competent. His aircraft were functional. His ship could steam 19 knots in calm seas, though rough weather would reduce that by 3 or 4 knots. What Short didn't have was any confidence that his pilots would follow those orders, and he was absolutely correct not to. Lieutenant William Fowler found U-569 on May 2 purely through the kind of random chance that dominates naval warfare. He'd been flying a rectangular search pattern 70 miles from the convoy when sunlight reflected off something metallic at the edge of his vision. He banked hard, dropped to 500 feet for better visibility, and spotted the submarine running on the surface, recharging batteries in what her crew assumed was safe open ocean. The textbook approach the one Fowler had been taught at Corpus Christi Naval Air Station required climbing to bombing altitude, calculating wind drift, approaching from upwind to minimize blast effects, and releasing depth charges from 1,500 feet while maintaining steady course and speed. This procedure maximized accuracy while keeping the attacking aircraft outside the blast radius of its own weapons. Fowler threw out the entire textbook. He pushed his Avenger into a shallow dive that brought him to 50 feet above the wave tops, advanced throttle to maximum power, and aimed directly at the submarine's conning tower. The German deck watch spotted him when he was 400 yards out, close enough that they could probably see his face through the cockpit canopy. They scrambled for the conning tower hatch with the panicked urgency of men who understood exactly what was about to happen. Fowler released his depth charges while his aircraft was so low that he could read the painted numbers on the submarine's hull. 3 explosions straddled the pressure hull amidships. The 4th detonated directly beneath the conning tower. U-569 went down stern first with all hands while Fowler's Avenger climbed through the debris plume, fragments of German steel rattling off his wings. He returned to Bogue, landed, filed a combat report describing his attack in clinical detail, and expected immediate disciplinary action for violating every established procedure for anti-submarine warfare. Instead, Commander Short read the report, initialed it, and quietly filed it without forwarding it to Atlantic Fleet Command. Short had made a command decision that would have ended his career if anyone had reviewed it through official channels. His pilot had just proven that low-altitude attacks worked better than approved doctrine, which meant approved doctrine was wrong, which meant every pilot in the Atlantic theater had been trained to attack submarines incorrectly. Rather than admit this through official channels, which would have triggered committees, investigations, and months of bureaucratic analysis, Short simply let his pilots continue doing what worked. The unofficial message spread through Bogue's ready room in hours: forget what they taught you in training. Go low, go fast, and release your ordnance before the submarine can dive. If it works, nobody will court-martial you. If it doesn't work, you'll be too dead for the court-martial to matter. Lieutenant Junior Grade Stewart Doty repeated Fowler's unauthorized tactics 3 days later. He caught you to 31 on the surface, transmitting position reports to headquarters the exact moment when submarine commanders felt most vulnerable because they could end crash dive while the radio operator was still encrypting messages. Doty's approach came in so low that German lookouts didn't spot him until he was already releasing his depth charges. The explosions detonated directly beneath the submarine's control room. The pressure wave buckled the hull in 3 places simultaneously. U-231 flooded so rapidly that only 7 crew members made it topside before she went down, and the frigid Atlantic water killed 5 of them within minutes. What made these attacks revolutionary wasn't just their effectiveness, it was their complete contradiction of everything the Navy had spent years teaching. Aviation doctrine existed for legitimate reasons. High-altitude bombing provided safety margins, gave bombardiers time for calculations, and allowed aircraft to escape their own weapon effects. The procedures had been developed by officers who'd studied physics, analyzed combat reports, and conducted extensive testing. But those officers had never faced a U-boat captain with 30 seconds to crash dive. They'd never experienced the reality that submarines on the surface were vulnerable targets, but submarines 20 feet down were invisible and untouchable. The window between spotting a U-boat and watching it disappear measured in seconds, not the minutes required for textbook approaches. Low-altitude attacks sacrificed safety and precision for speed and surprise. They were more dangerous for the pilots. Flying at 50 feet meant any mechanical failure would end in a crash with 0 time to recover. They produced less accurate bomb patterns because there was no time for careful aiming. But they caught submarines before they could dive, and in anti-submarine warfare, that single advantage outweighed every disadvantage combined. By May 9th, Bogue's pilots had destroyed 3 U-boats using tactics that violated regulations. Word spread through the escort carrier fleet faster than official communications channels could have managed. pilots compared notes during refueling stops. They described their attacks in ready room conversations that mechanics and deck crew overheard. The message propagated through informal networks that bypassed the entire command structure. Low and fast works. High and careful gets you a periscope wake and nothing else. The mechanics who ignored orders while pilots were rewriting attack doctrine. The real revolution was happening below decks, where nobody with rank insignia ever looked carefully. Aviation machinist mate second-class Robert Henderson stood in Bogue's hangar deck on May 6th, staring at a problem that official channels couldn't solve. His Avenger bombers had a combat radius of 250 miles, sufficient for protecting convoys, but inadequate for hunting submarines that operated at the edges of that range. Pilots were finding U-boats, attacking, then racing back to the carrier with fuel gauges reading empty. Submarines that survived the initial attack could surface and escape once the aircraft departed. The official solution would involve submitting an operational requirements document to the Bureau of Aeronautics, which would establish a committee to study range extension options, which would eventually recommend engine modifications or external fuel tank designs, which would enter testing protocols lasting 6 to 8 months before fleet deployment. Henderson would be fighting a completely different war by the time the bureaucracy approved anything. So he stopped waiting for approval and started welding. He fabricated auxiliary fuel tanks using parts scavenged from damaged aircraft. Each tank held 45 gallons of aviation fuel, enough to extend an Avenger's combat radius from 250 miles to nearly 400. The installation required welding mounting brackets inside the bomb bay, running flexible fuel lines to the main tanks, and connecting everything through a hand-operated pump system that pilots could control from the cockpit. The modification took 6 hours per aircraft and cost approximately $15 in materials that Henderson listed on supply requisitions as maintenance spare parts. It violated Navy Bureau of Aeronautics specifications because the fuel tanks hadn't been tested. The mounting system hadn't been approved, and the whole contraption introduced fire hazards that safety officers would have condemned immediately if they'd known it existed. Henderson installed these unauthorized fuel tanks on 3 Avengers before Lieutenant Commander John Croman, Bogue's Air Group commander, walked through the hangar deck on his evening inspection and noticed something that didn't match the aircraft as standard configuration. Croman stopped, examined the welded brackets and fuel lines, and asked Henderson what exactly he'd done to Navy property. Henderson explained the modification while mentally preparing for disciplinary action. Croman traced the fuel lines with his fingers, checked the pump mechanism, and asked how many aircraft Henderson could modify before the next patrol launched. The official memo Croman filed with Commander Short reported field maintenance adaptations to enhance operational capability pending formal Bureau of Aeronautics approval. The unofficial message to Henderson was simpler: install these on every bomber we have and don't bother me with paperwork. Aviation Ordnanceman First Class James Mitchell faced a different problem. The Wildcat fighters assigned to escort carriers carried 6.50 caliber machine guns, excellent weapons for air combat, but inadequate for attacking surface submarines. The bullets would punch through thin deck plating, but they lacked the penetrating power to reach critical systems inside the pressure hull. Pilots were strafing U-boats and watching their bullets ricochet off conning towers while submarines crash dive to safety. Mitchell's solution involved fabricating rocket rails from salvaged aircraft, tubing, and electrical conduit. Each Wildcat could carry to 5-inch high-velocity aircraft rockets under the wings, weapons originally designed for ground attack missions but never certified for the Wildcat airframe. The rockets weren't officially approved because nobody had tested whether the Wildcat's wing structure could handle the launch stress, whether the mounting system would interfere with the landing gear, or whether the additional weight would affect the aircraft's handling characteristics. Mitchell didn't care about official approval. He built the rocket rails, bolted them to a Wildcat's wings, and sent a pilot up for test flights. The pilot reported that the aircraft handled normally, the rockets fired without structural failure, and the explosive warheads could punch through submarine conning towers like tissue paper. That was sufficient testing as far as Mitchell was concerned. These modifications spread through the escort carrier fleet through the same informal networks that had distributed the low-altitude attack tactics. Mechanics on U.S. escort copied Henderson's fuel tank design after a boat crew member described it during a chance encounter in Norfolk. Ordnancemen on U.S. escort improved Mitchell's rocket rails by adding reinforced mounting brackets that better distributed launch stress. Aviation metalworkers on USS Santee developed drop tank systems that could be jettisoned before combat, reducing weight and drag. None of these innovations appeared in official technical manuals because official technical manuals required 12 months of committee reviews, engineering studies, and approval chains that stretched through multiple bureaucratic levels. The modifications were spreading faster than paperwork could travel, implemented by mechanics who understood that waiting for official approval meant watching pilots die, while perfectly good solutions sat on someone's desk awaiting signatures. Officers split into two factions. Traditional commanders like Captain Edward Hastings on U.S. escort threatened disciplinary action and insisted mechanics follow approved procedures to the letter. Pragmatic commanders like Captain Short pretended not to notice unauthorized modifications while quietly ensuring their own mechanics had access to the same innovations. The pragmatists won by default because their aircraft were sinking submarines while the traditionalists were filing maintenance reports. By mid-May, every escort carrier in the Atlantic Fleet was operating aircraft that violated official specifications in at least 3 different ways, and nobody with enough rank to stop it wanted to stop it because the modifications were working. The technology nobody expected while mechanics were improvising hardware solutions. British cryptographers and American engineers were deploying technologies that would transform anti-submarine warfare from reactive defense to proactive hunting. The Hedgehog system represented everything depth charges weren't. Traditional depth charges forced destroyers to pass directly over a submarine's estimated position before releasing them. The explosions would blind the ship's sonar for 15 minutes, during which the submarine could maneuver away into water disturbed by the blast effects. Depth charges killed submarines through brute force saturate enough ocean with enough explosives and eventually you'll hit something. Kill rates hovered around 4% because submarines were small targets in a very large ocean. British naval engineer Charles Goodhue approached the problem differently. Instead of attacking where the submarine was, attack where it's going to be. His Hedgehog system mounted 24 spigot mortar on a ship's foredeck for rows of 6. Each mortar launched a 65-pound projectile in elliptical pattern 250 feet ahead of the attacking vessel. The projectiles didn't explode on contact with water, they only detonated when they struck something solid, like a submarine's hull. This eliminated every problem depth charges created. Ships could fire Hedgehog salvos while maintaining continuous sonar contact. No explosion meant a miss, so sonar remained clear for immediate follow-up attacks. An explosion meant a confirmed hit and almost certainly a kill, because a 65-pound warhead detonating against a pressure hull would punch through the steel and flood the submarine faster than damage control crews could react. The mathematics of probability made Hedgehog devastating. 24 projectiles landing in a 140-foot ellipse gave each attack roughly a 25% chance of scoring at least one hit. By spring 1943, Hedgehog-equipped escorts were sinking one U-boat for every 5 attacks, of 500% improvement over depth charge success rates. The other technological revolution arrived in a black box that sailors called HFDF, high-frequency direction finding equipment capable of detecting and triangulating German radio transmissions. U-boats had to surface regularly to recharge batteries and communicate with headquarters. Every radio message gave away their position with mathematical precision. A single escort ship with HF/DF could determine the bearing to a transmitting submarine. 2 escorts comparing bearings could pinpoint the location within 5 miles. 3 escorts could fix a position accurate enough to vector aircraft directly to the target. The beauty of the system was that German submariners never suspected their communications network had become a targeting grid. Admiral Dinitz's wolfpack tactics depended on constant radio coordination. Submarines reporting convoy positions, headquarters directing attacks. U-boats coordinating movements to achieve simultaneous strikes. Each transmission drew a line across Allied plotting tables. The more submarines coordinated, the more precisely escorts could locate them. A typical engagement played out like this. DF stations would detect a submarine transmitting to headquarters. Escort carriers would launch aircraft to the coordinates while destroyers maneuvered into position. Avenger pilots would spot the surfaced U-boat and force it to crash dive. Hedgehog-equipped destroyers would reach the location while the submarine was still at shallow depth and slow speed, then attack with mortar salvos that didn't blind their sonar. If the first spread missed, they could attack again immediately instead of waiting for depth charge disturbances to clear. U-boat commanders found themselves hunted by enemies who seemed omniscient. Submarines surfacing to charge batteries would suddenly have aircraft overhead. U-boats transmitting convoy sightings would face destroyers appearing from apparently empty ocean. The technological advantages Germany had enjoyed through 1942 superior submarine designs, coordinated tactics, experienced crews had evaporated against countermeasures they didn't even know existed. 11 days that changed everything. May 10, 1943 began like any other patrol day for USS Bogue's Air Group. Pre-dawn launch, aircraft spreading out on search patterns covering 20,000 square miles of ocean, pilots scanning for periscope wakes or surface submarines or oil slicks or anything that might indicate U-boat activity. What the pilots didn't know was that for escort carrier groups Bogue, Card, Core, and Santee had been positioned to create overlapping search patterns across a 1,000-mile stretch of the North Atlantic. Admiral Royal Ingersoll had studied German operational patterns and positioned his carriers to cover convoy routes where wolfpacks traditionally concentrated. DF stations had detected 43 submarines transmitting across the operational area. For the first time in the Battle of the Atlantic, Allied forces had enough aircraft to hunt every contact simultaneously. Lieutenant Richard Rogers found U-174 at the absolute edge of his extended range 385 miles from Bogue, a location he could only reach because Henderson had installed unauthorized fuel tanks. The submarine was running submerged, conserving battery power. Nothing visible except a faint periscope wake that Rogers spotted only because the sun angle happened to be perfect. Rogers circled for 2 hours, something impossible without the auxiliary fuel tanks maintaining visual contact on the periscope wake while radioing coordinates to the carrier. U-174's commander had no idea an aircraft was tracking him. The submarine surfaced at 14:30 hours to recharge batteries in what the crew assumed was safe open ocean, 100 miles from the nearest convoy. Rogers for depth charges ended U-174 instantly. The explosions bracketed the submarine's pressure hull, collapsing it in multiple locations simultaneously. Survivors later reported that the boat flooded so rapidly that only 5 men reached topside before she went down, and the North Atlantic killed 3 of them before rescue arrived. The same day, USS Card-S aircraft destroyed U-176 using the new airborne radar systems that could detect surface submarines at 10 miles. The technology was so new that pilots were still learning to interpret the green scope images, but it worked. U-176 surfaced after dark, believing darkness provided protection. The submarine never detected the aircraft overhead until depth charges were already falling toward her position. May 11th brought 3 kills. Bogue's fighters caught U-5-8 on the surface, destroyed it with Mitchell's improvised rockets. The 5-inch warheads punched through the conning tower and detonated inside the control room. Core's aircraft sank U-456 in the morning using the same low-altitude tactics that Fowler had pioneered. Sanny's planes caught U-89 that afternoon. May 12th, May 13th, May 14th the killing continued with mechanical efficiency. German submariners began radioing distress calls that DF stations intercepted and decoded within hours. U-boat command headquarters in Paris received reports of aircraft appearing from nowhere, attacking at wave-top altitude, destroying submarines before they could crash dive. The reports described capabilities that shouldn't have existed. Aircraft operating hundreds of miles beyond their supposed range. Fighters carrying rockets, bombers with extended endurance. Escort ships detecting radio transmissions and vectoring aircraft to positions with impossible accuracy. Admiral Dunitz ordered submarines to remain submerged during daylight and surface only at night, but escort carrier aircraft began flying night patrols using radar guidance. The darkness that had once protected wolfpacks had stopped providing cover. By May 16th, German submariners were calling the North Atlantic the Valley of Death. Boats departing French ports with 50-man crews were disappearing with no survivors, no wreckage, nothing but oil slicks marking where they died. May 17th brought the worst single day. 6 U-boats destroyed across the North Atlantic by aircraft from all 4 escort carrier groups working in coordinated sweeps. Destroyers equipped with Hedgehog finished off submarines that survived initial air attacks. The coordination worked flawlessly, aircraft forcing U-boats underwater, then vectoring destroyers to locations for Hedgehog attacks, while submarines were still slow and vulnerable at shallow depths. U-273 survived for depth charge attacks through skillful maneuvering and lucky damage control. The submarine couldn't escape the Hedgehog spread that followed. 3 projectiles struck home, punching through the pressure hull at 400 feet depth. The implosion killed all 47 crew members instantly. The mathematics of submarine warfare had shifted in ways Admiral Dunitz couldn't reverse. Each Type 7 U-boat cost approximately 6 million Reichsmarks to construct, roughly $2.4 million at wartime exchange rates. Blumenvoss shipyard in Hamburg could build 1 submarine every 6 weeks using 500 skilled workers and materials that included precision instruments, high-grade steel, and advanced electrical systems. American escort carriers were destroying these engineering marvels using aircraft that cost less than luxury automobiles. The return on investment was staggering. Spend less than $50,000 and eliminate a $2.4 million submarine plus 50 trained crew members who'd required 18 months of training. Kaiser's shipyards were producing this destruction at rates German industry couldn't match. Vancouver launched 1 escort carrier every 32 days through spring and summer 1943. Each vessel cost $7 million and carried 27 aircraft worth approximately $1 million combined. That $8 million package could cover 20,000 square miles of ocean and sink an average of 4 submarines during its operational lifetime. Simple arithmetic showed an escort carrier would destroy roughly $9.6 million worth of U-boats before retiring from service. Even accounting for the carrier's construction cost, the United States came out $1.6 million ahead while simultaneously saving thousands of merchant sailors' lives and maintaining the supply lines that Britain needed for survival. German shipyards couldn't match American production rates because they couldn't match American industrial philosophy. U-boats were precision crafted using specialized components manufactured to exacting standards. Each submarine required 6 months of construction time because craftsmen assembled complex systems by hand. Blumenvoss could increase production slightly by hiring more workers, but fundamental bottlenecks existed in component manufacturing. There were only so many precision periscope assemblies available, only so many torpedo tube forgings, only so much high-grade steel that met naval specifications. American shipbuilding operated on opposite principles. Escort carriers used commercial-grade steel. Their engines came from merchant ship production lines. Flight deck catapults were simplified versions of fleet carrier systems. Electrical components used civilian manufacturing standards. Kaiser's workers weren't craftsmen, they were welders, riveters, and assemblers working 3 shifts around the clock. Quality control meant good enough to complete the mission, not perfect according to specifications. An escort carrier's lifespan might be shorter than a fleet carrier's, but it only needed to last long enough to sink submarines, and it accomplished that mission perfectly. By May 21st, the statistics had become undeniable. 41 U-boats destroyed in 11 days, more than 3 months of German submarine production. The wolfpack system depended on having enough submarines to saturate convoy routes. With boats disappearing faster than replacements arrived, Dönitz faced a problem no tactical brilliance could solve. His weapon system had become obsolete. The withdrawal that saved civilization. Admiral Karl Dönitz sat in his Paris headquarters on May 23rd, studying loss reports that read like an execution list. 41 submarines gone, over 2,000 trained submariners dead. Survivors from U-boat crews that had escaped described attacks by aircraft that appeared from impossible distances, operated at night using unknown detection methods, and coordinated with surface vessels in ways that suggested the Allies could read German minds. The intelligence reports painted a picture of Allied capabilities that shouldn't exist. Aircraft carriers, multiple carriers operating in the mid-Atlantic, where no carriers should be. Destroyers attacking with weapons that exploded only on contact with submarine hulls. Radio direction finding equipment tracking transmissions that German cryptographers had assured him were undetectable. Every assumption that had made the wolfpack system dominant through 1940 had collapsed. Submarines could no longer surface safely during daylight. Darkness no longer provided protection. Radio communications that enabled coordinated tactics were simultaneously revealing positions to enemies. The technological advantage was gone, replaced by Allied capabilities that rendered conventional submarine warfare suicidal. The mathematics were brutal and undeniable. German shipyards produced approximately 12 new U-boats per month. May's losses exceeded 3 months of production. At current attrition rates, the operational submarine force would cease to exist by autumn, not through gradual attrition, but through complete destruction faster than industry could replace losses. On May 24, 1943, Dönitz sent encrypted orders to all Atlantic U-boats: withdraw from patrol areas. Return to base. The wolfpacks that had nearly starved Britain were retreating. The withdrawal order represented Germany's first strategic defeat in a campaign they had chosen to fight. Lose the Atlantic and the Reich would face invasion from the west while bleeding to death in the east. May 1943 sealed that outcome, though it would take 2 more years of fighting to complete the process. The 11 days from May 10th through May 21st killed 41 U-boats and ended Germany's ability to wage offensive submarine warfare. The strategic consequences rippled outward with geometric progression. Allied merchant ship losses dropped from over 600,000 tons in March to under 200,000 tons in June. By July, losses fell below 100,000 tons monthly. Convoys that had suffered 20% casualties in early 1943 were crossing the Atlantic in August with 0 losses. The mathematics that had shown Britain starving by autumn reversed completely. Food imports increased, steel stockpiles grew. Aviation fuel flowed freely to RAF bomber bases preparing for the eventual invasion of France. General Dwight Eisenhower, planning Operation Overlord from his London headquarters, received updated shipping projections in July 1943. The numbers showed he could count on transporting 40 divisions across the Atlantic along with their vehicles, artillery, ammunition, and supplies without fear of catastrophic losses en route. D-Day became logistically possible because escort carriers had broken the U-boat threat. Without those 11 days in May, the invasion of Normandy would have been delayed by at least a year, possibly 2. Every month of delay meant thousands more deaths in concentration camps and millions more civilians suffering under Nazi occupation. Germany attempted to rebuild the U-boat force, but never recovered the initiative. New submarines leaving French ports in June and July found aircraft everywhere. Dönitz ordered development of snorkel-breathing systems that let submarines recharge batteries while remaining submerged, but these didn't deploy until early 1944. He demanded faster submarines with better underwater endurance, resulting in the revolutionary Type 21 U-boat design, But these vessels didn't enter service until April 1945 when the war was already lost. The technology that might have restored German submarine effectiveness arrived years too late because American pragmatism had seized the critical window and refused to let go. The philosophy that won the comparison between American and German military philosophy played out across every theater of the war, but nowhere more clearly than in the Battle of the Atlantic. Germany produced 85 Tiger tanks that cost $250,000 each and required specialized maintenance. America produced 49,000 M for Sherman tanks at $44,000 apiece that any mechanic could repair using spare parts from other Shermans. When a Tiger broke down, which happened frequently because the transmission couldn't handle the tank as weight, it required factory-trained technicians and parts shipped from Germany. When a Sherman broke down, the crew fixed it themselves using parts cannibalized from knocked-out tanks. Germany built 1,500 Focke-Wulf 190 fighters annually using precision manufacturing. America built 16,000 P-47 Thunderbolts per year on assembly lines. The Focke-Wulf was arguably the better aircraft in terms of performance specifications. But better didn't matter when American factories were producing 10 aircraft for every one German plane, and American pilots had fuel to train while German pilots were rationed to conserve petroleum that didn't exist. Quality versus quantity stopped being a debate when quantity became overwhelming. You could build the best tank in the world, but if the enemy had 50 tanks for every one of yours, you were still going to lose. You could engineer the finest submarine ever designed, but if the enemy was sinking your boats faster than you could build replacements, the engineering excellence was irrelevant. The escort carriers epitomized this victory through adequate mass production. They were unglamorous, slow, inadequately armored, and built using shortcuts that violated traditional naval architecture. They were also exactly what the Atlantic campaign required: platforms that could put aircraft over submarines cheaply and quickly enough to matter before Britain starved. 50 escort carriers eventually served in the Atlantic and Pacific theaters, sinking 69 submarines combined while protecting thousands of merchant vessels. Not a single one received the glory accorded to fleet carriers like Enterprise or Yorktown. Naval historians barely mention them in accounts of carrier warfare. But they won the war that mattered most, the campaign that made every other Allied victory possible. The mechanics who ignored regulations, the pilots who violated procedures, the commanders who looked the other way while their subordinates improvised solutions that would have gotten Soviet engineers shot and German technicians demoted. These were the people who saved Western civilization. Not through superior technology or brilliant strategy, but through organized chaos that produced adequate results faster than the enemy could respond. Robert Henderson never received a medal for installing unauthorized fuel tanks. James Mitchell never got promoted for fabricating rocket rails from scrap metal. Lieutenant William Fowler never appeared in newspapers for pioneering low-altitude attack tactics that contradicted every regulation in naval aviation doctrine. But between them and thousands of others like them, mechanics who built what worked instead of what was approved, pilots who survived by ignoring what they'd been taught, commanders who understood that winning mattered more than following procedures, they accomplished what seemed impossible in March 1943. They kept Britain alive long enough for America to build the invasion force that would liberate Europe. And they did it using merchant ships with flight decks welded on top, crewed by people who understood that sometimes the best way to follow orders is to ignore them completely. The North Atlantic in March 1943 was a graveyard. By June 1943, it was an American lake. The difference between those two facts was 11 days in May, when mechanics, pilots, and improvised aircraft carriers proved that adequate solutions deployed immediately beat perfect solutions that arrived too late. That lesson echoes across time with uncomfortable relevance. When facing existential threats, success doesn't come from waiting for optimal answers. It comes from implementing good enough solutions while your enemies are still planning their perfect response. The side that accepts adequate results delivered quickly will beat the side demanding flawless execution delivered slowly. Germany built better submarines. America built more escort carriers. Better lost, more won. That's not the story we like to tell about how wars are won, but it's the truth that mattered in 1943, and it's the truth that still matters today.